whenever I enjoy the beauty of nature, I just wonder how these leaves, flowers, rocks, everything around us have a pattern. It strikingly connects us with various designs on our fabrics, walls, etc. All of these designs we make are true inspirations from our nature. Almost every best designer say. So, numbers in the form of progressions are helping us unknowingly analyze them. For instance, you bounce a ball on the floor. Let's just say its height is decreased to half with every bounce, assuming its initial height to be h. So, the first bounce will be h by 2, second one being h by 4, and the third being h by 8, etc. Now, that's what we call it as geometric progression. Let's take a tour on geometric progression. Whenever we start learning any new topic, our biggest doubt is how is it related to a real life, or what is the application of the topic which we are learning in mathematics, especially mathematics. So here are the top 3 applications of geometric progressions, which is called in short GP also. The geometric progression is called in short as GP. So application number 1, population growth or decay. During this pandemic situation, our biggest concern is to limit the count of infected people. This picture here shows how the infection is growing rapidly. So initially there is a single person who is infected. Unfortunately, if the same person has unknowingly infected 2 people around him, then each person again infects 2 people around him. So thereby you can see at the first stage you find only 1. As the second level you can find 2 people, and at the third level you can find it as 4 people, whereas it increases like this rapidly. Okay, so this is a real time example of GP. And then application number 2, radioactive particles disintegrate with a fixed decay, which is in GP. So radioactive particles and radioactive substances you will be learning more in physics. So they have this half-life and they can decay, whose rate can be understood with the help of GP. Okay, the disintegration of that particles, radioactive particles, can be understood with the help of GP formulas. Okay, and then application number 3, medical field or hospitals. GP is used to calculate the amount of medicine in a person's body if you know the dosing schedule and the amount. Also, you can know how quickly the drug or medicine decays in the body. So maybe an example is an anesthesia. If a person is given anesthesia before the operation, he knows exactly how long it can withhold the person with anesthesia and how long will it take the person to come out of anesthesia. This is known by anesthesia doctor. And how do they calculate? It's using this GP again. So this can help the doctor to analyze the person's amount of medicine inside the person's body with respect to the dosing schedule and the amount. Thank you. So let us learn the practical GP, which is very useful, by learning some formulas in the next session and solving more problems based on this. Thank you.